To size transformer primary conductors, utilize the transformer's rated full load amps, or FLA, multiplied by 1.25. The overcurrent protection device, or OCPD, is specifically selected to protect the transformer itself from overload conditions and fault currents. A common practice is to size the OCPD approximately 250% of the transformer's rated current. However, it's crucial to understand that the primary conductors feeding the transformer do not need to be sized according to this elevated OCPD rating. The rationale behind this approach lies in the OCPD's function. It is designed to activate, or trip, only when an overload or fault condition occurs. Under normal operational circumstances, the current flowing through the primary conductors will remain below the transformer's rated full load amps. Consequently, the primary conductors are required to be sized only to handle the transformer's rated current, which is the FLA multiplied by 1.25. Let's consider some additional details. The National Electrical Code, or NEC, provides guidelines for transformer protection and conductor sizing. Specific sections within Article 450 address these requirements. It's important to consult the latest edition of the NEC for the most accurate and up-to-date information. When selecting an OCPD for a transformer, factors such as the transformer's impedance, inrush current characteristics, and the available fault current at the installation location must be considered. The OCPD's interrupting rating should be sufficient to safely interrupt the available fault current. There are different types of OCPDs available, including fuses and circuit breakers. Each type has its own characteristics and advantages. The choice of OCPD will depend on the specific application and the requirements of the electrical system. Fuses, for example, offer excellent current limiting capabilities, while circuit breakers provide overcurrent protection and can be reset after a trip. It is also important to consider the voltage rating of the transformer and the OCPD. The OCPD must have a voltage rating equal to or greater than the system voltage. If the voltage rating of the OCPD is too low, it could fail to interrupt the fault current safely. In addition to overcurrent protection, transformers may also require other types of protection, such as differential protection or sudden pressure relays. These protection devices are used to detect internal faults within the transformer. Differential protection compares the current entering and leaving the transformer. If there is a significant difference, it indicates an internal fault. Sudden pressure relays detect rapid increases in pressure within the transformer tank, which can be caused by arcing or other internal failures. The size of the transformer primary conductors will also depend on the ambient temperature and the type of insulation used for the conductors. Higher ambient temperatures will reduce the ampacity of the conductors. The NEC provides tables that list the ampacity of conductors for different insulation types and ambient temperatures. The conductors should be sized so that their ampacity is greater than or equal to the transformer's rated current multiplied by 1.25. It's also important to consider voltage drop when sizing the transformer primary conductors. Voltage drop is the reduction in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause equipment to malfunction. The NEC recommends limiting voltage drop to 3% for feeders and 5% for branch circuits. The length of the conductors and the amount of current flowing through them will affect the voltage drop. Longer conductors and higher currents will result in greater voltage drop. In some cases, it may be necessary to use larger conductors to reduce voltage drop. Grounding is another important consideration when installing a transformer. The transformer should be properly grounded to provide a path for fault current to return to the source. This will help to protect people and equipment from electrical shock. The grounding conductor should be sized according to the NEC. The grounding conductor should be connected to the transformer's neutral point and to the building's grounding electrode system. Proper labeling of transformers and related equipment is essential for safety and maintenance. Transformers should be labeled with their voltage rating, kVA rating, and other important information. The OCPD should be labeled with their ampere rating and interrupting rating. Wiring diagrams should also be provided to show the connections between the transformer, OCPDs, and other equipment. Regular maintenance is important to ensure that transformers operate safely and reliably. Maintenance tasks may include inspecting the transformer for leaks, checking the oil level, and testing the insulation resistance. The OCPD should also be tested periodically to ensure that they are functioning properly. If any problems are found, they should be corrected immediately. When working with transformers, it is important to follow all safety precautions. Transformers can be dangerous if they are not handled properly. Only qualified personnel should be allowed to work on transformers. Always to energize the transformer before performing any maintenance or repairs. Use appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential hazards such as electric shock and arc flash. Transformers play a critical role in electrical power distribution systems. They are used to step up or step down voltage levels to match the requirements of different loads. Understanding how to properly size transformer primary conductors and select overcurrent protection devices is essential for ensuring the safe and reliable operation of electrical systems. The 1.25 multiplier applied to the transformer's full load amps is a continuous load factor. The NEC requires that conductors be sized to handle 125% of the continuous load. A continuous load is defined as a load that operates for 3 hours or more. Applying this factor ensures that the conductor is adequately sized to handle the continuous current flow without overheating. Let's delve deeper into the practical aspects. Firstly, determine the transformer's full load amps or FLA from the nameplate. The transformer's nameplate provides critical information, including its kVA rating, primary voltage, and secondary voltage. Use the kVA and voltage values to calculate the FLA. Secondly, multiply the calculated FLA by 1.25. This will give you the minimum ampacity required for the primary conductors. Thirdly, select conductors with an ampacity equal to or greater than the calculated value. Consult the NEC ampacity tables to determine the appropriate conductor size based on its insulation type, temperature rating, and installation method. It is good practice to select conductors that are slightly larger than the minimum required size to account for future load growth and to reduce voltage drop. The location where the transformer is installed can affect the conductor sizing. If the transformer is installed in a hot environment, the conductors may need to be deaerated. Deaerating factors are provided in the NEC to account for high ambient temperatures. The conductors must also be protected from physical damage. This can be accomplished by installing them in conduit or raceway. The type of conduit or raceway used will depend on the environment and the requirements of the electrical system. It is also important to ensure that the conductors are properly supported. The NEC specifies the maximum spacing between conductor supports. Proper support will prevent the conductors from sagging or becoming damaged. The OCPD should be located as close as possible to the transformer. This will help to minimize the amount of unprotected conductor. The NEC specifies the maximum distance between the transformer and the OCPD. If the OCPD is located too far from the transformer, the conductors may be exposed to excessive fault current. The OCPD should be accessible for maintenance and testing. It should be located in a safe and convenient location where it can be easily reached. The OCPD should also be labeled with its ampere rating and interrupting rating. This will help to ensure that the correct OCPD is used. Transformers are available in a wide range of sizes and types. The type of transformer used will depend on the application and the requirements of the electrical system. Some common types of transformers include dry-type transformers, oil-filled transformers, and pad-mounted transformers. Dry-type transformers are typically used indoors. They are air-cooled and do not require any liquid coolant. Oil-filled transformers are typically used outdoors. They are cooled by oil, which provides better insulation and cooling than air. Pad-mounted transformers are typically used in residential and commercial applications. They are installed on a concrete pad and are enclosed in a tamper-resistant enclosure. The selection of the appropriate transformer for a specific application requires careful consideration of several factors, including the load requirements, voltage levels, and environmental conditions. Working with electricity is inherently dangerous. It is crucial to adhere to all applicable safety regulations and best practices to minimize the risk of electrical shock, arc flash, and other hazards. Always de-energize electrical equipment before working on it. Use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Be aware of the potential hazards and take steps to mitigate them. Proper training and experience are essential for working with electrical equipment safely. Only qualified personnel should be allowed to work on transformers. Regular inspections and maintenance are essential for ensuring the safe and reliable operation of transformers. Inspect transformers for signs of damage such as leaks, cracks, or corrosion. Check the oil level in oil-filled transformers. Test the insulation resistance of the transformer windings. Clean the transformer and surrounding area to remove dust and debris. Repair any problems that are found promptly. By following these guidelines, you can help to ensure the safe and reliable operation of transformers. The NEC provides specific guidance on conductor ampacity, derating factors, and overcurrent protection requirement. Consulting with a qualified electrical engineer or electrician can help ensure that the transformer installation complies with all applicable codes and standards. Remember that while the OCPD may be rated higher than the transformer's full load amps, the conductors feeding the transformer only need to be sized to handle the transformer's rated current plus the 1.25 continuous load factor.